Hello everyone, my name is Bhargav Sai. I am from AC department. Today my topic is methodology of the Taylor series based computations. First we will discuss about the introduction to Taylor series, then definition of Taylor series explanation, derivation of the Taylor series, next application of Taylor series where we apply the Taylor series, next convergence of Taylor series, error analysis of Taylor series. Next, limitations of Taylor series. What are the limitations of Taylor series? We will discuss here. Next, comparison with other approximations. We will compare this Taylor series with another methods. Conclusion and further direction. We will discuss this. Introduction. The Taylor series is a mathematical representation of a functions as infinite sum of their derivatives at a single point. Taylor series is nothing but a mathematical representation of a function at which infinite sums of derivatives at a single point is called Taylor series. This method is widely used in numerical analysis and approximate of complex functions. It is used in numerical analysis and complex functions. Understanding its mathematics Understanding its methodology is crucial for application in physics and engineering and computer science. It is somewhat crucial for application in physics, engineering and computer science. Next, we will discuss about definition of Taylor series. The Taylor series for a function f of x can be expressed as f of x equals to f of a plus f dash of a into x minus a plus f double dash of a into x minus a whole square by 2 factorial plus so on. Here, a is the point around which the function is expanded. F dash of a is nothing but f dash of x at which given function is derivated at a single point. F double dash of x a is nothing but f double dash of x at derivated double times. This series covers converge the function f of x within a certain radius of convergency. Taylor series expansion. Suppose f is a continuous on the closed interval a comma b and has a n plus 1 continuous derivatives on the open interval a comma b. If x and c are the points in the a comma b, then the Taylor series is expansion f of x about c. F of c plus f dash of c x minus c by f double dash of c by 2 factorial into x minus c whole square plus f triple dash of c by 3 factorial into x minus 3c whole cube plus so on is the expansion of Fourier series or Taylor series. Deriving the Taylor series. How to derive a Taylor series? To derive a Taylor series, you start by the computing the derivatives of the function at a point A. First, we have to find the derivatives of the each given function for single time, double time, and triple time, so on. Then substitute a point at which we have to finding the derivative. Each derivative contribute to the sum of the series weight by power of the x minus a. The general form of the nth term is f power n into a by x minus a whole power n by n factorial. This is the general form of nth term in the Taylor series, where f power n into a is the nth derivative evaluated at a point a. Next, application of Taylor series. Taylor series are essentially used in the physics to appreciate solutions different to different equations. It is used in the physics to approximate solutions in to different equations. In engineering, they are employed in controlling theory or signal processing for filter design. It is used in the engineering for signal processing and controlling theory. This series also plays a significant role in the computer graphing for enduring curves and surfaces. This also plays a vital role in the computer graphing for surfaces and curves. Next, these are the applications of Taylor series in engineering and computer graphing. Convergence of Taylor series. How to converge into Taylor series? Convergence refers to the behavior of the Taylor series as terms are added. It is nothing but the behavior of the Taylor series. A Taylor series converts to a function within a certain interval known as radius of convergency. Taylor series converges to a function within a certain interval. But suppose it converges into a certain interval for the given certain interval only. It's called as radius of convergency. Understanding convergency is crucial for ensuring accurate computing and approximately. For example, consider f of x equals to e power x. E power x equals to 1 plus x square by 2 factorial plus so on x power n by n factorial into plus r of n into f of x, where r of n of x equals to f of n plus 1 by c into x plus 1 by n plus 1 by whole factorial, where e power c by n plus 1 whole factorial into x power n plus 1 as n tends to infinity or r of n x tends to 0. Next we will discuss error analysis of Taylor series. What are the errors we analysis in the Taylor series? We'll discuss here. The error in a Taylor series approximation can be qualified using the Lagrange's remainder term. This term provides an upper bound on the error between the actual function and its Taylor polynomial. Analyzing error helps in determining how many terms are necessary for a desired accuracy. Next, we will discuss about the limitation of Taylor series. Here, we will discuss what are the limitations and how we are going to know how from which limit to which limits we have to use in Taylor series. Taylor series may delivers outside the radius of the convergence, making them unreliable in certain cases. Some functions like those which discontinuous or sharpened bends cannot be accurately represented by the Taylor series. Some functions like discontinuous functions and sharpened bend cannot be used represented by the Taylor series. This is one of the limitation. User must be equation and check the applicability of the series for a specific function being analyzed. Basic Taylor series e power x limit k tends to infinity summation k is equals to 0 to infinity x power k by k factor for minus infinity to infinity, where x lies between minus infinity to infinity. Cos of x equals to summation k tends to 0 to infinity minus 1 whole power k by x power 2k by 2k factorial for x lies between minus infinity to infinity. 1 by x minus 1 by 1 minus x summation k tends to 0 to infinity x power k for x lies between minus 1 to 1. These are the basic basic Taylor series formulas which we use for solving any function. Next, comparison with other approximations. Other approximation methods such as Fourier series and polynomial interpolation serve different purpose. Taylor series provide a local approximation, while Fourier series offer global representation of a periodic function. For example, Taylor series provides only for the local approximation, whereas Fourier series offer global representation. This is the difference between Fourier series and Taylor series. Evaluation the strength and weakness of each method helps in the selecting the approximate tool for a given problem. These are the strengths and weakness of the each method for selecting to solve a given problem. Next, conclusion and further directions. The methodology of a Taylor series based competition continues to evaluate with the ad- advertisement in competition techniques. The methodology for the Taylor series based on the competition continues to evaluate within the advertisement in the competition technique. Future research may focus on improving convergency rates or errors bounded for the complex functions. Future researchers maybe solve these complex functions, bounded errors, and etc. Taylor series remains a fundamental for tool in the mathematical in with a broad range of application across various fields. This presentation provides a structured overall of methodology of Taylor series based upon completing highlighting essential concepts and application. Thank you.